You are all very welcome to everyone getting ready for WAEC, NECO, and JAMB. I am so glad you're here. You know why? Because today we are tackling a topic that is, I promise you, a guaranteed high scorer: soil, water, and conservation. So let me ask you straight up, are you ready to master this topic? Because trust me on this, understanding soil water isn't just important for farming in Nigeria. Oh no, it is a favorite topic for the examiners. What we're going to do today, getting a real grip on it, is a direct investment in that beautiful grade you want to see on your results list. And look, just to prove to you that we're not wasting any time, we are sticking 100% to your official syllabus. We're going to talk about why soil water is so important. We'll break down its different forms, the gravitational, capillary, and all that. We'll touch on key ideas like field capacity, and then we'll get practical. How do we actually conserve soil? What's the deal with irrigation and drainage? Everything you see here, this is exactly what you need to know for your exams. No fluff. Alright, so here's our game plan, our roadmap to exam mastery. First, we'll dive into the secrets of soil water. Then we'll cover protecting and managing soil. After that, we're solving real exam questions, and we'll finish up with your ultimate exam summary. Let's get to it. Okay, let's jump right in. Section 1, the secrets of soil water. Seriously, this part is the foundation for everything else we're going to talk about. So let's make sure we get it right. So really, why is soil water such a big deal? I mean, it's just water, right? Wrong. Think about it like this. A plant can't just chew on solid fertilizer. No way. The water in the soil acts like a kind of soup, dissolving all those important nutrients, your nitrogen, your potassium, so the plant's roots can just drink them up. It's absolutely essential for things like photosynthesis. It helps to regulate the soil temperature so the roots don't get cooked. And it supports all those tiny vital microorganisms. The bottom line, and you need to remember this, is simple. No water, poor yields. No water, no food. Okay, this right here is a classic exam question, so listen up. Not all water you find in the soil is the same. There are three main forms. First, you've got gravitational water. After a heavy rain, it's all that water that just drains straight down, pulled by gravity. It moves too fast, so plants can't really use it. Then, on the other extreme, you have hygroscopic water. This stuff is like a super thin film of water that's clinging to the soil particles for dear life. It's held so tightly that plant roots just can't pull it away. So those two are mostly unavailable. But the one in the middle, capillary water. This is the star of the show. This is the VIP. This is the water held in the tiny little pores in the soil and is the main source of water that plants can actually absorb and use. If you remember one thing from this slide, remember capillary water. Alright, to really get this, you need to understand two key concepts that are like two ends of a scale. First, there's field capacity. Imagine it just rained heavily. After all that excess gravitational water has drained away, what's left is field capacity. The soil is perfectly moist, holding the maximum amount of water it can. Now, let's go to the other extreme, the permanent wilting point. This is, well, it's sad. It's when the soil is so dry that a plant starts to wilt. And even if you run and pour water on it, it's too late. It can't recover. It's literally the point of no return for the plant. So what does all this mean? It leads us to the most important definition of all: plant available water. It's simple, really. It's all the water that's in the soil between field capacity and permanent wilting point. That's the sweet spot. This is the water that your crops, your maize, your cassava, your yams are actually drinking to grow big and strong. This is the water that will determine your final yield. It's that simple. Excellent. Now that we've got the basics of soil water down, let's move on. Section 2, protecting and managing soil. This is where we get into the practical side of things, what farmers actually do. Okay, now one of the biggest enemies of good soil is water erosion. And let me tell you, the examiners love asking you to describe or even draw the stages of this process. So pay attention. It all starts with something small, splash erosion. Just one raindrop hitting bare soil, splash, and it knocks a soil particle loose. Then imagine millions of raindrops doing that. You get sheet erosion, where a whole thin layer of topsoil just washes away. If that continues, the water starts to form tiny channels. That's called real erosion. And if you let that go unchecked, those small reels join together to form huge destructive channels called gullies. You've seen them. It's a clear progression from bad to very, very bad. Now, this table right here, this is basically your perfect revision tool for those theory questions. It lays out some common soil problems and, more importantly, their solutions. Remember leaching. It's not the same as erosion. Leaching is when heavy rain washes the dissolved nutrients deep down past where the roots can reach them. Then there's bush burning. Yes, it's a fast way to clear land, but it's terrible because it destroys all that precious organic matter in the soil. And of course, continuous cropping. Planting the same thing like maize on the same spot year after year. It's like asking the soil for the same food over and over until it runs out. But look, there are solutions. Smart farming practices like crop rotation, using cover crops, and adding organic matter can fix these problems. Okay, so what happens when there isn't enough rain? Well, that's where irrigation comes in. We have to add water ourselves. Now, you have options. There's surface irrigation. Think of flooding a rice paddy. It's cheap, but honestly not very efficient. A lot of water gets wasted. Then you've got sprinkler irrigation, which is kind of like creating your own personal rain shower for the crops. It's better, but it can be expensive to set up. But the real champion, the most efficient of them all, is drip or trickle irrigation. This method is brilliant. It delivers water drop by drop right to the base of each plant. Almost no water is wasted through evaporation. Definitely pay attention to those efficiency percentages. They're a favorite for comparison questions and exams. And let's quickly run through a few other key practices you need to know. Mulching, that's just covering the soil, maybe with dry leaves or even plastic, to act like a lid and stop water from evaporating away. Cover cropping, that's planting something, often legumes, during the off-season. It's like giving the soil a protective blanket. And then there's drainage. Drainage is basically the opposite of irrigation. If you have too much water, you need to get rid of it with things like ditches so your plant roots don't drown. All of these are absolutely vital for managing your soil well. Okay, theory time is over. Now for the part you've been waiting for, the most important part, putting all this knowledge into practice. Let's get into section 3 and solve real exam questions. This is where we see how all this information turns into actual marks on your paper. Let's do this. All right, check this out. A typical JAMB question. It asks, which of the following types of soil water is readily available to plants? We just talked about this, didn't we? The key phrase here is readily available. So let's think. Option A, gravitational water. Nope, that drains away too quickly. Option B, hygroscopic water. No, that's held way too tightly for the roots to grab. So what's left?
Before you go, here are my top 5 personal exam tips for this topic. Number 1, always link soil water to nutrient availability. Number 2, be ready to draw and label the stages of gully erosion. They love that diagram. 3, know the difference between a cause and effect and a control measure. Don't mix them up. 4, memorize the relative efficiencies of the irrigation types. And number 5, here's a little secret for you. If you are in an objectives test and you see a question about plant available water, and capillary water is one of the options, it's almost always the correct answer. That's your cheat code, though. Listen to me. You have done the work today. You've covered the key concepts. You understand the processes. You've solved real exam questions. You are now prepared. You are ready. I want you to walk into that exam hall with your head held high, knowing you can tackle any question on this topic. Go and ace it. You can do this. If you found this lesson helpful, please do me a favor and like this video, share it with your classmates and friends who are also preparing for WAEC, NECO, and JAMB. And most importantly, subscribe to our channel right now so you don't miss the next topic. Also, be sure to visit www.examkp.com for thousands of free practice questions and answers.